One.
First part of this assignment is going to go back to tires. I know that we had an assignment on tire nomenclature, and the diagram was a little hard to read, a little fuzzy, and I want to explain some of these things to you. Tires are a significant part of any car because they are the actual engagement of the driving, the car on the driving surface. And so ideally, in a perfect world, you want a point-to-point interface with that driving surface. And I'll tell you a little later how they, in this video, how they try to maintain that point-to-point interface. But first thing that I have to tell you is that you're going to own a car, you're going to have to buy tires sooner or later, and if you call up a tire place and say, I need a set of tires for my car, they're going to ask is size of tire. Now the following numbers are the things that they want to know. The tire size goes like this. The first number on the tire size is, in this case, it's 215. And 215 is a measurement in millimeters of the width of that tire. The next number is called an aspect ratio, and I'll talk about what that ratio is. And that's the next number here. In this case, it's 65. Next, it's a letter. It's simply describing the composition of this tire. 96% of all tires produced in the world are radial tires, and I'll tell you about what that means in a little bit. And the final number will be this 15. That describes the diameter of the rim that this tire fits on. In other words, when they put the tires on the car, they're going to put them on the rims and attach the rims with lug nuts to the hub. Now, in talking about tires, you recognize that the point-to-point interface is of significance along the way. You want to maintain that point-to-point to get the best possible steering and traction along the way. Now, in order to do that, the width of the tire is simply how wide this tire interfaces with the road surface. But this aspect ratio is talking about this thickness of the tire versus that width of the tire. In other words, it's the profile. If you were to look at just the tire, the profile of this part of the tire. And that means that this is the thickness of the tire over the number that represents the width of the tire. And so you can see that the bigger the number, it means that you've got a large, the obvious number is the ratio of those two numbers. A smaller profile is something that you might want if you're going to a bigger rim along the way. I'll talk about that in a little bit. The radial is simply a mesh of metal that rides along the radial part of the tire. In other words, that interfaces the actual width, interfaces with the road surface. Now, that means that a radial tire is more firm. If you don't have a steel mesh, it's rather a sloppy ride. It kind of bends, and you go around a corner, and there's a lot of motion that you wouldn't have. The radial gives you a firmer surface interface along the way, and that's what you want. You want always to engage that surface and to do it with effectiveness and efficiency. And so that's why when I talk about radial and a steel mesh, a steel radial, that's just one of the belts around that. You'll see that there is a number of meshes. There's fiberglass meshes, 2 or 3 fiberglass meshes. There's some bias in there. It's a composition of various types of rubber, and then the actual mesh of steel. And all of that is then contained, all of it is then poured together, and that makes up this tire. You also have plies around the side to give it stability as well, but then you only have like 2 or 3 plies there, maybe 2 on the passenger. But that's what that R is standing for. The actual composition is a radial tire. 15 is a matter of the diameter. Now, this is a big thing nowadays because people are putting oversized rims on cars that then brings that center of gravity up. And so this is designed, the car is designed with this diameter of tire. Once you start increasing that, that means that the center of gravity goes up. So your cornering isn't as good, and you're going to have to overcome that with some suspension and trying to interface with the surface, the road surface. It's always about maintaining that road surface. And so they'll beef up the surface, the suspension, so that maintains its interaction with the road surface. But those are the numbers, 215, 65, 15, and the composition. Those are the things that they're going to want you to talk about as you then ask for the tire, the size of the tire. The next one, this gets into how they are going to maintain that road surface. There are three things that they're going to be, the suspension is designed around. It's called camber, caster, and toe-in. This is the camber. If you were to look at the car from the front end, in other words, if you're looking down the street and you're looking at the front end of your car, this is, and it's pronounced, you can see this oftentimes. The camber means that you're off-centering this. You can see the difference between the straight up perpendicular line to the road surface, and now all of a sudden you're just a few degrees out of that perpendicularity. So these things are leaning out. It looks like you're standing bow-legged almost with this surface. And what you want to do, again, you're trying to get that point-to-point contact along the way, and that's what they're trying to do, is that point-to-point contact, not the whole surface, but they want, it gives you better cornering, it rides better. Again, we're trying to get that point-to-point more effective, more efficient along the way. Now, when I talk about camber and caster, most cars being unibody construction, I'll talk about that later, unibody construction has this firmly in place. You can't really change this camber or the caster. It is actually welded in place, and there's no way you're going to change it. And what they're saying is, ideally, this is going to maintain. It's never going to change. On the other hand, once you have a front-end collision, that's why they say, yeah, there's a total loss of a car, because the geometry has changed that dramatically. It doesn't take much, and these dimensions are gone. Camber is one of those things that is dealt with when you have strut suspension. When I talk about a strut suspension, I'll show you that in a little while in the next film. What that is a gas-powered shock that has been pre-stressed and then a coil spring assembled. And so that strut is maintaining this angle right here. And the strut is built like that from the very beginning. The next thing I'm going to talk about, and you can see the strut right here. That's the quick strut that I was talking about. You see the coil spring, you see the gas, the gas. It's more or less a shock absorber, a gas operated that's been compressed already, pre-stressed. And you can see the positive camber, and most of the time positive caster is what you want. Most of the time, unless you've got the engine placed way out in the end, right in this direction. And the engine in this car is right in, the weight is right in here. So you're trying to maintain that surface-to-surface contact, once again, over the weight of this engine right here. So this is off-centered like that. And again, you can see this, when I do the other video, you'll see this is actually firmly established on that housing there, and this is on the steering lug right there, and you can't move that. It's not gonna move any more than what it is right now. The only thing that most domestic cars would do, oops, wrong one, is tow-in. They talk about when you get your car aligned, which is always a funny thing to me, but alignments are called tow and go. They'll align the car for a tow in, and that's it. That's all they can do. As I said, the other two dimensions are firmly designed and they can't change. Whereas this is the one that they can change. And they change that as I talk about things, they'll change that with a rack and pinion, the ends of the rack and pinion. And the rack and pinion is right here. That's a steering device, though it's steering. And you can then push these out that way or pull them back in. And what you want, again, is a point-for-point relationship with the interface. And so that's why these are at an angle. Now, this is exaggerated for the purpose of looking at this, and you probably wouldn't be able to see it, but most of them are toe-in. Once you get a toe out, all of a sudden, any of these that I'm talking about will give you an improper wear process. In other words, this, if it's toe out like this, then you're going to have an inner type of wear pattern right here. Same thing with the other two. You'd have an interface that would develop some poor wear patterns in your car. They'd wear out. In a radio, if you have problems, most of the time, it'll either be this surface or this surface that it wears out. And when it wears, you'll look at the where it's actually supposed to be interfacing. Good tread right there, but it's almost becoming round. The tire is becoming round in these corners. And it'll wear to the point where it'll wear out, and you'll see the frayed edges of that steel mesh, that radial steel mesh right in the corner there. And so you really have to maintain these types of, now when I say that, it's not like, oh, I got to get my car aligned every year. I wouldn't do that at all. My thing is, these guys that work on these alignments are going to tell you one thing. They're going to say, they're going to put it up in the rack, oh, you're going to need new tie rod ends, both inner and outer. We can do that for you, but we can't do an alignment because they're so bad we can't maintain these distances like we should. Well, I've yet to bring one into a place like that. And when they're telling me, yeah, I got to have all this work done, it's all a game that they're playing. Or if you're trying to be on their side, it's a liability. They don't want you coming back and saying my tires are worn out because you didn't do a good job. Now, when I talk about here, let me go back here. Oop, where am I going here? Oh. No, I lost my thing. When I talk about the tires and the tire interface, it's the biggest thing is everybody talks about the inflation of the tire. Now, as you looked at that nomenclature, there's a specific design of a tire, and the and again, and it's usually right in here. You'll see the actual inflation rate on the side, small, very small, tiny letters that you can't read in the dark. But the inflation is big because that's going to give you that point-to-point contact that they're talking about. In underinflated tires are going to wear out a lot quicker. They're going to give you a poor ride. And in fact, if you let go of the steering wheel, and it'll drift off to one side or the other depending on which tire is underinflated. So that's always something good to check. And I mean, check it often, once a month. Check the tire pressure because that's how significant that tire pressure is. It doesn't take long. Underinflated tires will wear out. When you look at these tires, it's significant to recognize it's all part of the suspension. This is the last part of the suspension, and changing these tires or the size of these tires changes the suspension. Once you change the suspension, that means that strut is going to have to be changed. This quick strut right here is going to have to be changed. In other words, you're going to have a stiffer ride because all of a sudden the center of gravity has changed along the bigger diameter. The interface is going to be the same, but that'll bring this hub, where this diameter is, up here. raising the whole car up. So the cornering is bad. And what you want to then do is maintain that interaction by stiffening the ride. That'll give you a better idea about tires and what you need to do to order a tire and what they're looking for as far as a tire. I'm going to do some other things with the next video with regard to the engine bay and some of those concepts. So this will conclude anything that I'm going to have on tires. There'll be some questions with regard to everything that I talked about right here at this time. Right. Thank you very much. Good.